Formalized derivations in thermodynamics. So we have this one. First formalized revision is on the work is equals to integral of P dV, where PV is equals to C. So this PV equals to C would mean P1 B1 is equals to P2 B sub 2, or equals simply to C. How to derive the formula using the integral of PdB is that from this one you solve P on this one, substitute here, so your P is equals to C all over V. Substitute that one, becomes work is equal to integral of your P is, you have that one, C dV all over V. But this one in integration is equals to C ln of V2 all over B1. Integral of du all over u equals to ln of u plus c. But the limit here is B1 and B2. So you have that one, ln of B2 minus ln of B1. But in logarithm, ln of B2 minus ln of B1 could mean ln of B2 over B1. So you have this work C ln of B2 over B1. But C here, so refining this formula, your C equal to PB. So your PB could mean P1 B1 or P2 B2. So you have that one C, have that one P1 B1 ln of B2 all over B1. This one is the work formula on this curve PB equals to C. But here, when curve is equivalent to PB to the power n is equals to C, you just follow the formula there. Work equal to integral of PdB. So the same process as this one, you have that one, work is equals to integral of P dV. But your P there, but your P on this one, you have that one, P from that one equals to C transpose this V, there you have that one minus n. So B minus n. Substitute this one, your P on this, your P is equivalent to this one. So you have that one, work is equals to integral of your P is C V minus n, then you have that one dV. So you have that one dV. So integrating this one would mean here equals to C V integral of u to the power n du equal to u n plus 1. Your u is this one, minus n plus 1 all over minus n plus 1. Of course, you have plus c there, but your limit here would be equivalent to V1 and V2. So this one would simply mean here equals to, that one is C V, that one, minus n plus 1 all over minus n plus 1. But your V there, your limit would be B1 to B2, so this one equivalent to C, that one, this one is V2 since that upper limit, so C V2 minus in, could be written this one as B2 to the power 1. Then you have that one minus C, the same thing, B1 there, V1 minus in V1 to the power 1 over minus in plus 1. So simplifying this one, you can have this one, but C V minus n, CV minus n would mean P, but here V2 would mean P2. So your CV2 minus n would mean P2, following this equivalent there. So this one would mean this one is P2 since subscript is 2 and following this equivalent. So you have that one P2, that one is B2 to the power 1 is simply you can write that one B2. And the same thing here, CB1 minus n would mean P1. This subscript is 1, so would mean P1 B sub 1. Subscript this one is could no longer be written here as the same as here. You have that one minus n plus 1. Or to avoid this sign here, you can have that one, or your work the equivalent to, you can have that one P1 B1 minus P2 B2 all over in minus 1. So these two formulas here for work, this one would solve when the curve given is P bit power n equal to C. For instance, problem would say that the polytropic process expanded following the curve PB to the power 1.2 is equals to C. So this derivations of the formula would mean to be used for finding work. You can use work on this one and this one. Your n refers to the power. But here, this formula for the work would be used if the curve is PB is equals to C. There is no power. Because in thermodynamics, PB to the power n or sometimes PB to the power K, your K there would mean isentropic or adiabatic. 1.3, usually value is 1.3, but other than that value 1.3, it is a polytropic curve here. It is a polytropic. So you follow this formula P with power n and this one, and we will have later on problems that could be solved using the derivation of the formula, because formulas are sometimes could not be fixed. It depends on the problems, the conditions of the problems given. So we'll have more examples on this one, but these two work formulas on the ideal gas will be used, this one and also this following on this one. So either this formula could be used depending on the condition of the problem.